That is the hope. I am Dr. Kristen Mark. I am a professor here in health promotion. I run the sexual health promotion lab. A couple of my students are in here. And I have a PhD in health behavior, but I also have my MPH is in biostats. So that's the reason that I'm kind of like the go-to stats person in the department. I do qualitative and quantitative research, but my formal training is definitely pretty quant heavy. And I consider myself an applied statistician. So I do a lot of well, not a lot anymore, but consulting work for like organizations who need things done stats-wise, which means that I'm able to translate the sort of super high-level geeky stats stuff to the people who are working in communities. And that's something that a lot of stats people, I find it's like difficult to work with if they don't have that applied piece. So I want us to talk about stats in a really applied way today. I'll show you a few tables, like for example, like the chi-square critical value table. People don't use those. So what you learn in your stats classes, it's just, frankly, like not always that useful. So I try and provide information that's a little bit more useful. In my graduate training, I learned everything that I knew about stats from actually doing research. And you can talk and learn about stats in a classroom all day long, but until you actually use the software, until you're actually like having to solve problems on the ground while you're doing research, stats classes are just, it's hard to apply that knowledge. So I'll try my best in today's class. I'm going to show you some SPSS output and stuff like that, but we're not going to be working directly with SPSS, obviously. You don't all have computers in front of us. But feel free to interrupt at any point in time if you have questions. I plan to be here until about 5:45 or 6. And we aren't going to take a break. You might be able to take a break after that. But I've got to be somewhere else at 6, so I got to go straight through, okay? All right, so let's just do a bit of a refresher in terms of like terminology. Research objectives. So this is kind of broad, right? This is like thought of as the umbrella term. You've got to think about what exactly you want to answer in your as you create hypotheses or research questions. So that's your overall goals or your research objectives. These are the goals for the study. And you need to have that in order to possibly create research questions or hypotheses. So an example of this study will examine the relationship between activity breaks as measured by teacher report and on-task behavior for children using systematic observation. Or it might be, so you're just listing what you want to find out and how you're going to do that. There's a lot of different ways to collect data. I don't know if you guys have talked about that in here. A lot of the work we do uses survey-based methods. If you want big data sets, that's really the best way to go. There's also a lot of people do, you could do, like many of you who are in exercise science might do like physiological measurements that generate quantitative data. The analyses that we're going to talk about today are going to be the same no matter what. It's just a matter of what your level of measurement is. Research questions narrow down. So your research objectives are first, then you have your research questions, which narrow down, and I'll send these slides to Dr. Irvin as well. So these are specific questions. And some studies require research questions, right, instead of hypotheses. If there's not much research that's been done in that area, then there's no point in trying to generate hypotheses if you have no idea the direction of what you might find. So in my field, for example, in sex research, there's so little research done on a lot of these topics that we are often using research questions instead of hypotheses. But if there's been a lot of work done to lay sort of the groundwork for what you're looking at, then sometimes you can make directional hypotheses. And that would be, and we're going to talk about that in a minute, sorry. So determining a research question. You can't do this until you've looked at the literature. I'm sure you guys have done that in this class, right? Research methods. I hope that by now we're halfway through the semester. Hopefully you've gone to the literature. You also need to think about feasibility. Can you even answer the research question? Don't pose a research question that's not answerable because you're just going to end up having data that you can't use. Also specifying what population you're looking at. So you want to make sure that that the population that you're targeting matches what you're interested in answering. And if you have an intervention, making sure that you're considering what other things might be impacting that intervention. And we use these criteria that are called finder criteria in order to assess whether something is a good research question. So is it feasible? Is it interesting? So, sometimes students of mine in my lab will propose a question that might be really interesting, but there's no way that we can afford to pay participants what we would need to pay them to get them to do those things, right? So that rules it out. It has to meet all of these criteria. Is it novel? You can't know if it's novel unless you've looked at the literature. Is it ethical? Will the Institutional Review Board approve? This is something we do have trouble with in sex research. We have a study right now that it is definitely ethical, but we're asking people to bring recorders into the bedroom with them and record themselves having sex. This is bringing up, obviously, red flags at IRB for will the partner know that they're being recorded? We're not enrolling the partner in the study, we just want the woman's recording. So it makes it kind of difficult to know for sure if we're meeting these criteria, but I can argue that we are. And then, is it relevant? Why does this matter? What's your take-home message? What's the thing that's going to really make this be important? So how many of you have worked with research questions more than hypotheses? Most of you are working with hypotheses the most? Yeah? You're doing research? How many of you are actively doing research currently? A handful of you, okay. So hypotheses are so you can develop them from research questions. So sometimes we'll have a research question and it'll have like 3 hypotheses that follow it, right? So we have this broad research question and then 3 hypotheses. Sometimes though, you're able to just have the hypotheses on their own. Because sometimes, as I mentioned, it's not appropriate to use a hypothesis, so you have to rely on those research questions. The null hypothesis is when there's no difference. Hopefully you already know this. This is reviewed, yes, yes. Okay, good. So there's no correlation, there's no relationship between your variables of interest. And the goal is to reject that and accept the alternate hypothesis. That's what you want to happen. So that they will be related. So why do we need stats? Despite the fact that I have a biostats degree, that my master's is in biostats, I really hated statistics in undergrad. I thought that it was really horrible, and that's probably because I really hadn't done real research yet. But once I got into my master's program, I started getting really involved in research and realized, oh, stats are actually super systematic, and there's just like these steps of things you have to follow, and that really makes sense to me and is awesome because you can really do this. So they provide this objective map, this objective way to answer research questions. And that's something that qualitative research, for example, it can be a little bit more difficult to work with qualitative data and stay objective because you always have to outline what your biases are. Do you guys know the difference between qualitative and quantitative data? Yeah. Can someone just say what that is? Katie, what's the difference?
The difference between qualitative and quantitative. Qualitative is measuring things that you can't really assess numerically. So it'd be like attitudes. Well, sometimes you can.
Okay.
Sometimes you can, but it's like individuals. And quantitative is like something that you can analyze numerically.
Yeah, so the main difference is numeric assessment, but qualitative is answering more broad questions that you need people's context for, that you need them to give you rich, qualitative data is super rich data. It's really, you're able to take quotes that form themes and that makes meaning out of the data. Not super objective. Whereas stats and numeric data, you circled a 3, you're a 3. You know, that's just how that goes. Now, there is a whole field called psychometrics, and I did a lot of my dissertation based on psychometric analysis of scales. And what that does is it makes sure that we are indeed being objective, making sure that, yes, we're meeting these criteria of objectivity. So we have descriptive techniques, and that's things like how many people in the United States identify as LGBTQ, right? That's descriptive. It's not really telling us much about them aside from what their identity category is. We have correlational techniques, things like, are people who identify as LGBTQ typically more stressed out? Do they experience minority stress compared to people who are not part of that community? And then we have like differences among groups. So you could look at, in our field, unfortunately, gender differences are often focused on. So a lot of our work works to try and push away the gender differences. It tries to say, no, there's actually more similarities than differences. But we can test this by looking at differences among those groups and looking at whether there are significant differences. So I'm going to talk about each of the tests that do that, and we're going to look at the most common tests used. So they tell us if there's a significant difference or that there's a significant effect. They also tell us the strength of the relationship. And increasingly in journals, we're being required to provide what are called power statistics. So we're being required to provide effect sizes so that it's not this p-value of p is less than 0.05 anymore that's the criteria for reporting results, but rather what is the meaning of that effect? Is that a strong effect? Is that a small effect? What's the effect size? Because, for example, if we have a data set that has like over 10,000 people who participate, which happens regularly with our studies, you're going to get significant results. It's going to meet the crucial p is less than 0.05. It's going to meet that, no matter what. So we have to look at what is the effect size here. And then there's the different statistical techniques. And also the very important note that cause and effect, that correlation is no proof of causation. Have you guys talked about that in this class yet?
Yes.
A little bit? Okay. So what would be a study that would allow you to talk about causation?
An experiment.
An experiment? Would it? What would make it allow you to?
Because you control for a bunch of factors, you introduce independent variables, and we can say, since we changed this, and these are different,
Okay.
It's supposes we're going to get the same, this is a causal effect.
Are these with people?
They can be.
Okay. If they are you able to control sort of like everything in their life?
No.
No, we can't control everything. We can't control all of the variables at play. But we can get, as you said, as close as you can to causation. Another way to do that is longitudinal methods. So by measuring something over the course of time, we have a lot more confidence in our ability to say that one thing caused another. It's not perfect. And really, we should be relying on talking about things in terms of their relationship to one another rather than a cause and effect, unless we're really, really convinced of that. So, a crucial part of stats, and actually the part of stats that I hated the most when I first started doing statistics more, was figuring out what statistical tests you need to use. And do you guys have an assignment, I think, in this class where you're going to have to propose a study and say what statistical test you're going to use? Yeah, she's still doing that? Okay. So this is a really crucial part, and I'm going to give you a great handout. In fact, I will pass this along now, that provides you with some context for this. So what I'm giving you now is a table that provides information related to the type of variable that you might have, and it allows you to see what tests you need to be using. There's a bit of groundwork you need to do in order to make sure that your stats are going to work for you once you collect your data. my mind, because of being a statistician, my mind immediately, whenever my lab is sitting around and creating research questions, and whenever we're talking about a new study, I am automatically thinking about the stats. Because you need to do that. You can't collect data in one form, as you're going to see from this handout, and also as we talk more about this. You need certain types of variables to be able to answer certain questions. So if you ask a question and it's not a continuous outcome variable, then you're really limited in the types of analyses you can do. So you really need to correctly set up the data in the early stages of work in order to make this happen. I always have students who are doing theses or whatever, come up with a table that provides them with, here's my research question, here are the variables I'm using, here are the types of variables those are, and here's the analysis I'm going to do. So that I can very easily look and see, oh no, this actually isn't going to work because you're collecting categorical data and you want to do a regression. Can't do that. So this is very, very important, and is why people should consult with statisticians before they collect their data, rather than when your data's already collected and you're like, crap, I've got this reviewer who's told me that I can't publish this because they want me to recollect my data. So making sure that you're doing this prior to data collection is really crucial. You could end up having too few subjects in a group if you don't do this. Having non-valid or non-reliable testing instruments, or not being able to compare one measure to another. So often we'll compare, we'll look at sexual behavioral, we'll collect sexual behavioral data. And so if we say to somebody, what's your desire, what has been your desire to engage in sex over the past 30 days? And then at the next wave of data collection, we ask them, what's it been like over the past 3 months? Then we can't compare those data to each other. So you really need to be careful with making sure that the wording is what you want it to be.